Welcome back. This is the third video in our series on naming organic compounds as required in the CAPS document for the NCS curriculum for grade 12. Now this problem, we need two things. We need knowledge and memorization and a strategy to handle this problem. Our strategy at this stage is to take the organic compound from the back and work our way up to the front. But you'll see very soon that there's a lot of information that you need to memorize. At this stage, we learn to identify alkanes, alkenes, alkynes, haloalkanes, and alcohols. Make sure that you are able to identify the functional groups of each of these. Can you answer the following questions? How does an alkene look? To which homologous series does a butanol belong? And how would you identify an alkyne? What is the functional group of an alkyne? If you struggle with any of these questions, then it's very important that you go back, watch the first two videos again, and do the revision exercises to make sure that you have this knowledge before you continue. Okay, the next two homologous series that we're going to deal with in this video is the aldehydes and the ketones. You will see they look very similar. In both cases, we have an oxygen with a double bond that is connected to the carbon chain. There's my aldehyde, and there is the ketone. So what is the difference? In the aldehyde, the double bond O will always be at the end of the carbon chain. With a ketone, the double bond O will be in the middle of the carbon chain. Aldehydes with a double bond O at the end of the chain ends with L. Examples is pentanol or ethanol and so on. Ketones with a double bond O attached to the middle of the chain ends in -one. Examples propanone, pentan-2-one, and so forth. Okay, let's look at examples as they are written. Here you can see I have my carbon chain. On my last carbon, there's a double bond O attached, making this an aldehyde. Another example, a great big carbon chain. There you see those four. And on the very last carbon, I have a double bond O attached. In my ketones, I have a long chain over here, and in the middle, I have my double bond O. Now look at this example. It appears as if the carbon is, or if the double bond O is attached to the carbon at the end. But if you look closer, you'll see that this is actually my entire chain, and that this double bond O is connected to the middle of the chain. The chain is just bent and not in a straight line. Now let's look at the names of the different aldehydes and ketones. In this one I call ethanol. This aldehyde is called 2,2-dimethyl butanol. Ketones, this one is called heptan-4-one. And the last example that I have here is called propanone. Remember still, if you don't know how to get to the first part, we'll get to that. At this stage, the important thing that you need to be able to identify is the last part of the name and to know where this comes from. This is from the functional group or the homologous series. The functional group is this little structure inside the formula that gives away to which series this belongs, to which homologous series. The homologous series is the groups like the aldehydes and the ketones and the alcohols and the haloalkanes to which these organic compounds belong. Okay, so let's consolidate that information again. Now I've mixed up the alkenes, alkynes, alkanes, alcohols, haloalkanes, as well as the ketones and the aldehydes. Quickly go and see if you are able to get these differences before we continue with the next video.